Zeal Education Society, redefining excellence.
Hello student. In the previous video lecture of basic electrical engineering, we have learned the mutually induced EMF and self-induced EMF. In the self-induced EMF, it is the EMF induced in a coil due to change of its own flux linked with it is known as self-induced EMF. The coil has a certain property which opposes any increase or decrease of current or flux through it is known as coefficient of self inductance, and this is analogous to somewhat inertia of a body. That is, inertia, it is difficult to set heavy body into motion, but once it is in motion it is equally difficult to stop it. On the similar way, the self inductance opposes any increase or decrease of the current flowing through the coil. But once the current is allowed, it is equally difficult to stop it also. So this self inductance can be defined by the three ways. The first one is Weber turns per ampere in the coil, or it can also be defined as flux linkage per ampere in the coil. So Weber turns per ampere in the coil, or flux linkage per ampere in the coil. Thus we can write self-inductance denoted by L equal to N phi upon I, where N phi is flux linkage in Weber terms and number of turns of the coil, phi flux in Weber, and I current flowing through coil in ampere. So the inductance, self-inductance L equal to N phi upon I, its unit is Henry and denoted by capital H. So this is the equation 1. So the second method, in second method it is given in terms of dimensions of the solenoid. So in terms of dimensions of solenoid, we know that L equal to N phi upon I. Also, flux phi equal to mmf upon reluctance equal to Ni upon L upon mu 0 mu r A, and therefore phi upon I equal to N divided by S. Now putting this equation in one, putting 2 in 1, L equal to n, and replace phi by I, n upon s equal to n square upon s. Therefore, equal to n square, s is nothing but L upon mu 0 mu r a. Thus, L equal to n square upon s, or L equal to n square upon L upon mu 0 mu r a, or L equal to n square, this mu 0 mu r a upon L. Thus, the self-inductance is inversely proportional to length of the solenoid and directly proportional to square of number of turns. So, if the dimensions of the solenoids are fixed, dimensions means area and the length is fixed, the inductance is directly proportional to n square. Therefore, self-inductance L is directly proportional to n square if the dimensions of the solenoids are fixed. Now let us take the third definition. We know that L equal to n phi upon I. Take the cross product, n phi equal to Li. Multiply both sides by minus 1. Therefore, minus n phi equal to minus Li. Now differentiate both sides with respect to t. Therefore, E equal to EL equal to minus n d phi by dt equal to minus L di by dt, and this is nothing but EL, self-induced EMF, equal to minus L di by dt. This negative sign indicates that the induced EMF opposes or acts in opposite direction. This, if you consider the magnitude only, we can write EL equal to L di by dt. If EL equal to 1 volt, di by dt equal to 1 ampere per second, then EL equal to 1 volt. Thus, coil is said to have self-inductance of 1 Henry. Coil is said to have a self-inductance of 1 Henry if 1 volt is induced in it when current through the coil changes at the rate of 1 ampere per second. So, in this way, we have defined the self-inductance. If EL equal to L di by dt, if we consider EL equal to 1 volt, di by dt equal to 1 ampere per second, then self-inductance L equal to 1 Henry. Thus, we can define the self-inductance like this. A coil is said to have a self-inductance of 1 Henry if 1 volt is induced in it when current through the coil changes at the rate of 1 ampere per second. So, in this way, we have learned the three definitions of the self-inductance L. The self-inductance L, self-inductance is denoted by L, its unit is Henry and denoted by capital H. We have studied the three definitions and the three equations we have generated. The first one is L equal to N5 upon I. The second, in terms of dimensions of solenoid, L equal to N square upon S or L equal to N square upon L upon mu0 mu r A. Now it can be written like this. Now if the dimensions of the solenoids are fixed, then we can say the self-inductance is directly proportional to square of number of turns. Now, according to third definition, EMF generated in a coil due to self-induction is known as denoted by EL, and EL equal to minus L di by dt or by magnitude L di by dt. So we will solve three numericals based on three equations.